Pre-Calc. So I wanted to finish up this video that we started, or these notes that we started on for section 1.4. So we're just going to go through the last two parts real quick. And we're going to look at composition, which we kind of started very briefly, and we're going to look at implicitly defined functions. So to begin with, let's start with compositions of functions. Okay, so we have m of n of x, and we're going to find n of m of x. So let's start with m of n of x, which we can then write as m of n of x. So what this means is we're going to take n of x, which is this guy, the square root of x minus 2, and we're going to plug it into m of x, which is this guy, for x. So the way that would look is wherever I see x, I'm going to replace it with the square root of x minus 2. Okay, so I have x squared, so I'm going to have the square root of x minus 2 squared, plus 5 times the square root of x minus 2 plus 6. I could square the square root here and get just x minus 2, which would then combine. I can combine negative 2 and 6, and I get x plus 4 plus 5 times the square root of x minus 2. So now we need to look at the domain. Okay, the domain of composition functions is really defined by two things. It's defined by the initial function, the one that's kind of getting plugged into the other one. Okay, and it's defined by the result. And in this case, both of those have a square root of x minus 2 in it in some way. And so the domain is pretty easy to analyze algebraically. Our domain needs to be all the numbers for x that would make x minus 2 greater than or equal to 0. In other words, x needs to be greater than or equal to 2. Okay, so we can take a look at the graph. Okay, so here are the two functions individually. The first one is, so this is the square root function, and this is just a parabola. So you can type in Desmos m of n of x. You can't use that little circle as far as I know. Okay, and you can see it's this fun green thing. Okay, kind of looks like a square root function, but then it kind of straightens out. It's kind of interesting. All right, so the domain we came up with is all x greater than or equal to 2, which you could see is the domain of the n of x and our composition function. Okay, so now we're going to go ahead and do the other direction. So with the other direction, we're going to do n of m of x, which means we're going to plug in m of x into n of x. Okay, so we're going to plug this guy into that guy. So where I see an x here, I'm going to substitute this entire thing. So this becomes the square root of x squared plus 5x plus 6 minus 2. We can clean that up a little bit. X squared plus 5x plus 4. Okay, so it's a square root of a quadratic. The square will not cancel because it's not, everything's not being squared. We got to just leave it like that. Okay, so our domain, if we think of the domain of m of x, it's a parabola. It's all real numbers. Okay, so there's no problem with that. But this ending result has a square root. The square root is a problem. We need to think about what values of x would make that greater than or equal to 0. I think we talked about how to do this in the very end of chapter P, where you can solve it graphically. Okay. So before I show you the result, this is x squared plus 5x plus 4. You think about where is that greater than or equal to 0. It's everything above here, so everything to the left of negative 4 and everything to the right of negative 1. So now let me show you, let me remove that. There is n of m of x. And so you can see the domain is really determined by -4 and -1, which was the parabola that's under that square root. Okay, so interesting the way it looks. Okay, last we have implicitly defined functions. Oh, I should write the answer down. So our domain is all x less than or equal to -4, all x greater than or equal to -1. You guys can do interval notation. I'm just doing this quickly. Okay, describe the graph of the relation. So we have two functions, or they're not functions, they're relations. Just a reminder, relation is what you call anything that relates x and y. So what we're going to do is we're going to rewrite these relations that are not functions as two implicitly defined functions. So we're going to separate it into two functions. So the first one is x squared plus y squared is equal to 4. So if you were to graph that, hopefully you remember that would be a circle. Specifically, it's a circle with a centered at the origin and a radius of 2. Okay, the radius comes from the square root of 4. This is not a function. It doesn't pass the vertical line test at all. So if we wanted to pass the vertical line test, we have to separate it. We have to separate it into two parts. And usually that means we're going to separate it into the top part and separate it into the bottom part. And so when we do it that way, we can have two pieces of functions that make up the circle. Okay, so how do we find the equations of those things? Specifically, we need to solve for y. All right, so I'm going to subtract x squared from both sides. I get y squared is equal to 4 minus x squared. Then I'm going to take the plus or minus square root of both sides. Be careful here, you cannot turn that into 2 minus x. It is not 2 minus x. You cannot sort of distribute a square root over any addition or subtraction. Don't let me forget the plus or minus. So you actually get two functions here. Your first function is the positive square root of 4 minus x squared. The other function is the negative square root of 4 minus x squared. Those are functions. Let me show you what they look like. So let's hide our circle. So y equals square root of 4 minus x, not cubed, squared. It's the top of the circle. And if I do y equals negative square root of 4 minus x squared, you get the bottom of the circle. So you get the circle that we had, but it's now a function, because if you look at each piece is a function. Okay. So let's do the last one. Let's do b. We have x squared plus 2xy plus y squared is equal to 1. So this one we got to get y alone, and actually the way that we're going to do that is we're going to factor it. Okay, this is a perfect squared trinomial. Specifically, it is x plus y squared is equal to 1. So by the way, we should look at what this looks like. X squared plus 2xy plus y squared is equal to 1. So Desmos has the ability to understand what these graphs are when they are like this. But old graphing calculators couldn't do it. There it is. Well, that's interesting. Let's get rid of our circles. It's a pair of parallel lines. So let's see if we can figure out why we get a pair of parallel lines. Okay. So what I'm going to do now that I've factored this is I'm going to square root both sides, plus or minus. Sorry about that. Okay, so when I square root both sides, I'm going to get I'm going to get plus or minus 1 there. So then, or I'm going to get x plus y is equal to plus or minus 1. So then I'm going to separate it. One of them is going to be x plus y is equal to positive 1. The other one's going to be x plus y is equal to negative 1. These are lines. We saw that we got parallel lines. If you subtract x from both sides, kind of rewrote it, this is y equals negative x plus 1. It's got a y-intercept of 1 and a slope of negative 1. This one would be y equals negative x minus 1. So if we go and look back, kind of zoomed in a little bit, there it is. Has a y-intercept of 1 and a y-intercept of negative 1. They both have a slope of negative 1. Alright, that's it, and we're going to have another video for 1-5.